we are going to see something about bonding. As the word says bonding, don't you just remember when you think about bonding, you can think about friendship, isn't it? Friendship is the type, is a relationship where you have bonding. Just like that, these elements also can be bonded. Okay, they have to be bonded, otherwise they cannot exist alone. We can't exist alone. We need a friend to just share everything, or we need a friend to whom we can transfer something. Similarly, here are elements which have this bonding. Okay, now when we come to this bonding, there are three types of elements that we generally have. One is, the first group are metals. They are called as metals. The second group are non-metals. And the third group are inert gases, or they are also called noble gases. When you come to metals, as we have seen under atomic structure in the 9th standard, these metals will always have 1, 2 or 3 valence electrons. Okay, and non-metals would have 5, 6 or 7 valence electrons. Okay, noble gases, if we see, the first element or the first noble gas is helium, which has 2 valence electrons, and all others, if we take neon, it has 8 valence electron, argon again 8, okay, 2, 8, 8, then krypton and xenon, all of them have 8 valence electrons and 2 valence electrons. This is where the common thing about this is they are perfectly obeying the duplet or octet rule. Okay, see, duplet means an atom tends to be stable when it has 2 electrons in the outermost shell. Okay, so duplet rule is 2 electrons in the valence shell. That makes the atom stable. Okay, when you come to octet, remember octopus. How many arms does an octopus have? 8. Octagon, 8-sided. Octet, so 8 electrons. So when an atom has 8 electrons in the valence shell, it tends to be stable. This is how the stability is reached. And here we have these inert gases which already have 2 or 8 in the outermost shell. So they perfectly obey this, and therefore they have a stable electronic configuration. They are stable. See, when you go for a feast or a party or something, and you are full, you are just full enough, then you don't need any more. That is the kind of state that these elements are, these noble gases are. They have a stable electronic configuration. But here are these metals and non-metals which are running short of this octet or the duplet rule. Okay, this is when the need for combination comes. And when they need to combine or when they need to bind with each other, they form bonds. How do they form bonds? They can form only when by attaining 8 or 2 in the valence shell. Except for hydrogen, all others, or lithium rather, all others would have 8 in the valence shell. How do they get 8? If they are metals, they have to lose these electrons because they have only 1, 2 or 3. So they would lose electrons. And if they are non-metals, they would gain these electrons. How much would this gain? 3 electrons or 2 electrons or 1 electron, thereby becoming stable and obeying the octet rule. This is how bonding goes about. Now let's go into the types of bonding that we have. Now going to the types of bonding. See, if I have two chemistry textbooks and my friend Rita does not have a chemistry textbook, and what do? She is my friend and she doesn't get it anywhere. I transfer my chemistry textbook to Rita. What am I doing? I am transferring it to her. I don't need to get it back again. I am just transferring it and she is accepting it. Thereby, I am losing one of my textbooks and she gains that textbook. This is how bonding goes in a type of bonding called electrovalent or ionic bonding. Electrovalent or ionic bonding. So here there is basically transfer of electrons. This happens by transfer of electrons. Okay, when electrons are transferred, ions are formed. And there is always an attraction between oppositely charged ions, and that is how ionic bonding is formed. Ionic bonds are formed. Now the next one is, supposing I'm having an apple and Rita again has an orange, and so what we do, I share my apple with her and she shares her orange with me. So there is equal sharing. Okay, so we can have a bonding by sharing of electrons, and that results in covalent bonding. Okay, this comes due to sharing of electrons. This is the basis. Now this sharing can be of two types. It could be equal or it could be unequal. Okay, if it is equal sharing, and there is also unequal sharing of electrons. Both are possible. If it is equal sharing, it results in non-polar covalent bond. But if there is unequal sharing, it results in polar covalent bond. Okay, so these are the two types. Yet there is one more type where the sharing comes from one side only. Okay, then it is called as coordinate covalent bond. Okay, here sharing from one side only or from one element only. We'll be seeing these things in detail later on, but as of now we need to know the classification: equal, unequal and coordinate covalent bonding. So these are the three different types of sharing bonds that can be formed. One is non-polar, one is polar, and this is coordinate covalent bonding, or this is also called as dative bonding. So these are the different types, and we are going to move straight away into ionic bonds or electrovalent bonds. And in your syllabus, we have, in the 10th standard, we have what is called as electron dot structure. We can just skip the atomic orbital structure because we have already seen that in the 9th standard. We are going into the electron dot structure. Okay, now examples of this is, the first one is sodium chloride. For anything that we do, the first step that you do should be to write the electronic configuration. Okay, so this is to do with sodium and chlorine. Okay, sodium has an atomic number 11 and chlorine has an atomic number 17. So what will be the electronic configuration? Electronic configuration is the arrangement of electrons in an atom. How it is arranged? How many electrons are there in each shell? How many shells are there in an atom? That is given by electronic configuration. Now for sodium it would be 2, 8, 1. That is the electronic configuration. For chlorine is 2, 8, 7. So this gives us an idea that there is 1 valence electron for sodium and 7 valence electrons for chlorine. Okay, and it is easier for sodium to lose this 1 electron and it's easier for chlorine to gain that 1 electron. That is how an ionic bond is formed between sodium and chlorine. Okay, now let's move into the electron dot structure. Whenever we write the electron dot structure, one important thing that we must remember is we take into consideration only the electrons of the valence shell. We don't need to put 11 dots. We don't need to put 17 dots. We are only going to have 1 dot for sodium and 7 dots for chlorine. Maybe you can differentiate with different colors or different shapes. That doesn't matter. Okay, so the electrons of the valence shell are represented by dots. This only is electron dot structure. The electrons by dots, that is electron dot structure. Okay, now moving on to sodium. As I told you, there is only 1 electron, so that means there is only 1 dot that is needed. Let's take it as 1 dot here. Okay, this combines with chlorine, which has 7 electrons in the valence shell. So we would represent it by 7 crosses like this. Okay, now this has to transfer one of this electron to the other, that is to the chlorine atom. So it transfers it. Once it transfers it, this becomes sodium ion. It's a cation. Okay, and chlorine gains this 1 electron from sodium atom. Okay, and it becomes anion. See, ions are formed. Okay, now how do we get this plus and minus? See, sodium has 11 electrons. Okay, so sodium with 11 electrons and 11 protons. What is it doing? It is losing 1 electron. It's not losing proton, it's only losing electron. Okay, so minus 1 electron. How much it would have? 10 electrons and 11 protons. Now it has 10 electrons and 11 protons. Now the charges of electrons are negative, charges of protons are positive. Then it is plus 11 minus 10, that gives you plus 1. That's how you get this 1 plus. Now go to chlorine. Chlorine has 17 electrons and 17 protons. Okay, and what is it doing? It's gaining 1 electron. Okay, so 1 electron. So after that, it becomes 18 electrons and 17 protons. Again, charge minus 18 plus 17, that gives you minus 1, and that is why you get minus. Okay, so this results in a compound called sodium chloride. This is how electron dot structure is done. Okay, ionic form, sodium atom loses one electron to give sodium ion. This is an ionic equation. Similarly, chlorine atom gains that electron to give chloride ion. See, when it is in the ionic state, you don't call it chlorine, but it's called as chloride ion. Okay, so this is how ionic equation is written, and this is the electron dot structure of sodium chloride. Okay, so this is called sodium chloride. Two terms that we learn. Okay, there is an atom, there is an ion. So what is the difference between an atom and an ion? If you see there, does this have charge? No. Okay, so this is a neutral particle. Atom is a neutral particle, whereas these are charged particles. Ions are charged particles. Atoms can exist independently or may not. For example, we thought about the inert gases. Inert gases can exist independently. Ions will always exist independently in solution. Okay, so may or may not exist independently. Whereas ions will exist independently in solution. Okay, so these are the basic things that we need to remember. The main part of this is, now when it is in the atomic state, it does not obey, okay, may or most of the time may not obey the octet or duplet rule. That is why it needs to go into bonding, whereas ions obey octet or duplet rule. So these are the important differences between atom and an ion, and ion can be of different types, positive and negative. Okay, and also we should remember about oxidation and reduction here. Loss of electron is oxidation and gain of electron is reduction. Both these things happen during an ionic bond formation. Now we move on to the second example. It's calcium oxide. Again, this is an ionic bond that is formed between calcium and oxygen. So let us see the atomic number of calcium is 20 and oxygen is 8. So how will we write the electronic configuration? For calcium it is 2, 8, 8, 2, and for oxygen it is 2, 6. So this is the electronic configuration. Now when we come again to the electron dot structure, how do we write this? Remember, only the last valence electrons alone, last shell alone. So we take calcium and we just have 2 dots here. Okay, and oxygen, with how many dots must be there? There must be 6 dots, and let us represent that with 6 crosses like this. Now when they both are going to react, this electron is transferred, this electron is also transferred. Thereby it becomes calcium, because it has lost 2 electrons, it becomes 2 plus. Loss of 2 electrons, excess of 2 protons there. Similarly, oxygen would have 8 altogether. That means 2 electrons in excess. Okay, therefore it is 2 minus. This is how we get calcium oxide. See, plus 2 and minus 2 will get cancelled and then it becomes a neutral compound, calcium oxide. Okay, the next example is magnesium chloride. Okay, for magnesium, the atomic number is 12 and for chlorine, atomic number is 17. So when we write the electronic configuration, it would be 2, 8, 2 for magnesium and 2, 8, 7 for chlorine. Now there is a hitch. Now magnesium needs 2 electrons to be given out and chlorine can accommodate only 1. One chlorine atom can accommodate only 1. So what it should do, magnesium is frantically in search of something else and all that it can do is it would request one more chlorine atom. One more chlorine atom, please come, take my electron. Then only I can be stable. So, in the place of 1 is not sufficient because it does not have a capacity more than 7. Therefore, only 1 can be accommodated here and another one goes to another chlorine atom. So, we write it like this, magnesium here, and how many electrons here? There are 2 electrons. So, we can put the 2 valence electrons on 2 sides and we have the chlorine, 1 chlorine atom this side and another chlorine atom here. Okay, and this chlorine atom has 7 electrons. Similarly, this chlorine atom also has 7 electrons. So, this electron is transferred here and this electron is transferred to this chlorine atom. These two are added. Now, after this addition, what would happen? From magnesium, 2 electrons are gone but protons are still there. So, this gets 2 plus, 2 protons more. This chlorine atom would have 8. That means 1 electron more. Okay. Therefore, this becomes minus. Okay. Then this chlorine atom also would have 8, which means there is 1 more here, minus. So, the charges ultimately would be plus 2 and minus 2, that becomes 0 and that gives you magnesium chloride. This is how magnesium chloride is formed. How does this form? Magnesium, from magnesium 2 electrons are gone to give Mg2 plus. Now, 2 chlorine atoms are taking part in this reaction. Therefore, we should not write it as Cl2 minus, which means it is 1 atom, but 2 chlorine atoms are gaining 2 electrons, 1 electron each. So, it becomes 2Cl minus. Okay, these are the ionic equations of magnesium chloride, and for calcium, calcium will lose 2 electrons to give Ca2 plus. At the same time, oxygen would gain those 2 electrons to get O2 minus. So these two are the ionic equations of calcium oxide, and these two are the ionic equations of magnesium chloride. So this is how magnesium chloride is formed. Okay, so magnesium undergoes oxidation and chlorine atom undergoes reduction to give chloride ions, and thereby magnesium chloride is formed. So these are the 3 examples of ionic bonding.